This is Plant-Based Briefing, Animals in Education and Animals in Research, from the Society for Humane Science at forhumanescience.org. And I'm your host, Marian Erickson, and this is the curated content plant-based podcast, where I research and find articles related to healthy, compassionate, or sustainable living, get permission, and read them to you here. Today's articles are a bit shorter than most. I try to keep each episode to about 10 minutes, so I'm going to combine two shorter ones into today's one episode. They're from the Society for Humane Science. It's a Canadian nonprofit organization working to promote better science without animals. Their mission's to build an ethical culture of science that respects animal life by promoting the reduction and replacement of animals in teaching, research, and testing. I first heard the founder, Dr. Elizabeth Ormandy, on the Animal Voices Vancouver podcast, where her discussion about animals used in high school biology classes brought back such awful memories for me. So I'm so glad organizations like hers are doing this wonderful work. Now let's get to today's plant-based briefing. Animals in Education and Animals in Research by the Society for Humane Science at forhumanescience.org. Animals in Education, Elementary and Secondary Education. Across North America, dissection of real animal specimens remains a prevalent practice in elementary and secondary science education. 79% of science teachers in British Columbia still do dissection with their students. Key species include frogs, rats, fetal pigs, and many more. While many of these animals are purpose-bred by supply companies, some are wild-caught. Marine species are often bycatch from the fishing industry, and some, for example fetal pigs, are acquired via the food production industry. Some of the key issues with elementary and secondary school dissection are as follows. 1. It is a completely unregulated practice. 2. It embeds a cultural attitude that using animals as tools instead of subjects in science is okay. 3. It is not as good for education compared to non-animal teaching methods. 4. It harms the environment through the use of harsh chemical preservatives. 5. It costs schools thousands of dollars per year. And 6. It necessarily excludes many students who don't want to participate for personal, cultural, or religious reasons. Of the hundreds of school districts across Canada, only a few have a student choice policy in place. A student choice policy grants students the right to opt out of dissection without penalty and requires that teachers give prior notice of the dissection and meaningful alternatives to those who opt out. To date, Abbotsford, Burnaby, North Vancouver, Vancouver, West Vancouver, all in BC, and York Region in Ontario school districts have student choice policies on dissection in place. What are the alternatives? While there are many different types of non-animal teaching methods like videos, photographs, etc., that can be used in place of traditional dissection, we prefer to use interactive learning tools like 3D models and virtual dissections. Non-animal alternatives to dissection have been shown to be better than dissection in terms of how well they help students meet their learning goals. Non-animal alternatives can also save schools a significant amount of time and money each year. For more information, head over to our Humane Science Education Program page. Tertiary education, college, university, medical, and veterinary school. In 2018, 408,690 animals were used in higher education in Canada. A wide variety of species are used in all kinds of educational programs, everything from behavior labs to dissection. Some of the key issues with tertiary-level animal use in education are as follows. 1. A regulatory loophole means that most animals used for dissection at universities are not under the national oversight or counted in national numbers. 2. Dissection and other uses of animals embeds a cultural norm among students that animals are tools rather than subjects. 3. Animals are expensive. And 4. Use of animals excludes certain students. At the university level, student choice policies might exist in theory, but in reality, universities tend to make the courses that require dissection optional, rather than making the dissection itself optional. This means that a certain percentage of students choose alternate courses, and some biological science disciplines may be losing talented students to other disciplines that do not require dissection. What are the alternatives? There are many different replacement alternatives for tertiary-level education, everything from computer simulations for physiology to clay modeling for advanced anatomy to Trauma Man for training military medics. Some of our favorite resources are Rescue Critters, training mannequins for veterinary specialists, Syndaver, dissection mannequins for anatomy training, Interspectral, CT scan data with virtual dissection for anatomy training, Anatomage, virtual dissections of humans and animals, Z-Space, virtual reality dissections for undergraduate and medical training, and Sheffield Bioscience programs, multiple tutorials that offer non-animal labs for physiology, pharmacology, neuroscience, and more. Professional training, for example, veterinary and animal research technicians. Animals are used for the training of animal research technicians who, because of their role in animal research, are required to be competent in certain skills, including animal handling and taking blood samples. Replacing animals in the training of professionals like research technicians might at first seem highly challenging. However, it is possible that the formal training such as the Registered Laboratory Technician (RLAT) course can be done using non-animal alternatives. Then the research technician would learn animal handling skills on the job under close supervision of a mentor. This would mirror the type of training medical surgeons receive, where they intern with qualified mentors and learn first by observation, then by doing tasks under close supervision. Then only when the mentor assesses them as competent can they work alone. Animals in research. Animals are used in many different types of scientific research. One way to categorize the types of research animals are involved in is to establish whether the research is basic or applied. Basic research is exploratory, an open-ended search for more information for the sake of increased knowledge or for scientific advancement. Applied research is used to answer a specific question that has direct applications to the world. Basic research. Basic research is driven by curiosity and a desire to expand knowledge. This type of research is not technically applicable to the real world in a direct way, but instead enhances scientists' understanding of the world. Basic research has traditionally studied life at the cellular and molecular level to establish what mechanisms and metabolic pathways are involved in the essential life processes of living organisms. Numerous animal species are involved in basic research, mice being the most common. An example of basic research would be a study looking at how caffeine consumption affects the brain. The goal of the research is simply to increase the amount of knowledge on this particular topic, not to come up with a practical solution to a problem. Applied research. Applied research refers to scientific study and research that seeks to solve practical problems and is used to find solutions to everyday problems, cure illness, and develop innovative technologies. An example of applied research would be a study investigating which treatment is the most effective for reducing anxiety. One major use of animals in applied research is the creation of so-called disease models, where animals are given specific diseases so that either progression of the disease can be studied or so that new drug treatments for the disease can be developed. Increasingly, genetic engineering techniques are used to create genetically engineered animal models. These genetically engineered animal models are predisposed to develop certain diseases that can then be studied. The creation and use of genetically engineered animals for their use in research pose certain ethical and animal welfare concerns. These have been discussed in detail in the Canadian Veterinary Journal. In brief, the major concerns are 1. The invasiveness of procedures used to achieve the genetic alteration of interest. 2. The unanticipated welfare concerns that might arise. 3. The high numbers of animals involved in the creation of a new genetically engineered animal line. And 4. How best to draw ethical limits in terms of what is acceptable regarding the genetic engineering of animals. However, despite these concerns, genetically engineered animals are increasingly used and now represent the majority of animals used in science. This is because genetically engineered animals are thought to be more accurate disease models. However, this claim has been questioned by some scholars who are advocates for the replacement of animals in research. What are the alternatives? There are many different non-animal methods that can be used for both basic and applied research. Techniques include in vitro assays, adverse outcome pathways or AOPs, organ on a chip, organoids, and computational modeling. You can learn more about these techniques at our Alternatives to Animals page and our blog posts. You just listened to Animals in Education and Animals in Research from the Society for Humane Science at forhumanescience.org. And if you're interested in a short documentary, I think it's 16 minutes long. I highly recommend the film Test Subjects. It follows 3 young, ambitious graduate students who were eager to become scientists and change the world, but they had to stand up to entrenched beliefs in education and the scientific community in order to not harm animals needlessly and to perform better science. You can find it at testsubjectsfilm.com, and I'll put a link in the show notes as well. Thanks for listening.